Hi, I'm Roger Scheuer. I'm an engineer, and in 1999 I invented a controversial space propulsion system to be used in satellites and rockets.
Well, it's finally here, the revolutionary electromagnetic drive.
So M-Drive is going to change the world because, first of all, it will give us flying cars.
The one that's going to give us hover cars.
It will give us unrestricted access to anywhere we want to go to in space.
And not just any hover cars that will take you from London to Sydney in about 2.5 hours. It's going to solve global warming.
And eventually it will help provide energy for the world and solve the global warming problem.
It could take you to Mars in just 70 days or to the moon in just 4 hours. It's amazing. And yes, it's just past peer review. So for starters, I'm going to ignore all the stuff about this violating the law of conservation of momentum, which is kind of the scientific equivalent of saying, then a miracle happens. And I'm just going to take their results at face value, just to see how revolutionary this drive actually is. Now, firstly, I should make it clear that the inventor of the drive, that's the guy making the remarkable claims, weren't the same people who actually did this recently published study. They seem to be independent. So according to their peer review paper, it produces a whopping 40 to 80 micronewtons of force for 80 watts of power. That's about the energy of one of these energy-guzzling incandescent light bulbs.
So that thing there is about a 100-watt light bulb, a power-guzzling light bulb.
Now, for those of you who are impressed with 80 micronewtons, that's 80 millionths of a newton. Let me just put that into perspective. I mean, let me say I'm a big guy. I weigh about 100 kilos.
So this is your sort of typical human. It's about 100 kilos, give or take. It's about 200 pounds. You know, I'm worrying too much about the details here.
And I experience gravity, an acceleration of 10 meters per second squared towards the ground. That means that I exert a force on the ground of about 1,000 newtons. That's effectively my weight. Now, this EM thruster produces 80 micronewtons of thrust. So let's be generous and call it 100 micronewtons. 100 millionths of a newton. So only to provide enough thrust to lift me off the ground would require about 10 million of these engines.
So M-Drive is going to change the world because, first of all, it will give us flying cars.
Oh, but it gets better if we look at the power to thrust ratio. So they say they get about 100 micronewtons for 100 or so watts. So that's about 1 million newton of force per kilowatt of power. Kilowatt of power is 1,000 watts. So cool. So in order to lift just me would require, I kid you not, a gigawatt of power. That's not to send someone back to the future. That's just to lift one person off the ground. So, perspective time. The entire electrical generating capacity of America is 1,000 gigawatts. So the entire grid of America, using the EM drive, could lift about 1,000 people off the ground. And those people are about 100 kilos apiece. So the entire electrical generating capacity of America could put about 100 tons in the air for 1,000 gigawatts. Now, a Chinook helicopter can put about 20 tons in the air for about 2 megawatts of power. So 5 of them could lift, again, about 100 tons for about 10 megawatts. That means that regular motors are about 100,000 times more effective than the EM drive, the M drive. Now, for those of you trying to picture what a factor of 100,000 looks like, consider a regular guy who can lift, say, 10 kilograms.
And that's about 10 kilos, which is not light. It's about 1/10 of my body weight.
Now let's make him 100,000 times stronger. So, rather than lifting 10 kilograms, he can now lift 1,000,000 kilograms, or 1,000 tons. That's the equivalent of lifting 10 super heavy tanks, or one of these super stupid tanks that Germany never quite got around to making in World War II.
By side with a modern tank, the Rat would have been colossal. Weight 1,000 tons, length 35 meters.
So let's see, their device produces this amazing 100 micronewtons, about the same force as 10 millionths of a kilogram. So it's about the same force as the weight of a single drop of water.
Okay, so the EM drive produces about 10 milligrams of thrust. This is a milligram balance. So let's do 1 drop of water. Which, according to this, weighs about 40 milligrams. So that's 4 times the thrust of the EM drive. All right, let's get that down to about 10 milligrams if we can. Yeah, it's 15 milligrams. That's close enough, right? So that's about the actual thrust that the EM drive produces.
And it can do that for about 100 watts of power.
So if you were to just take the energy that a typical human consumes per day and express that in terms of a power rating, your typical human actually consumes about as much power as a 100-watt light bulb, one of these energy-gobbling light bulbs, which is curiously about the same amount of energy that the EM drive needed to produce 10 milligrams of thrust. Okay, so let's see what I can produce in the way of thrust just by using my breath. So I can produce about 100 times as much thrust just using my breath as the EM drive.
So you got that. Both me and the EM drive run at about the same power, 100 watts. The EM drive produces a massive 10 milligrams of thrust. Now, I don't know how much of my 100-watt running power went into blowing on those scales, but it probably wasn't that much. And even at that, I produced about 100 times as much thrust as the EM drive. But there's more. I mean, let's just see if the convection current of a 100-watt light bulb can produce more thrust than the EM drive.
Okay. So just put that on the top there. Now we see what that will do. Oh, levitating a piece of plastic. That. There you go. My little light bulb just about produces enough thrust to keep them airborne. So how much does that weigh? And weighs about 50 milligrams.
That's about 5 times the thrust of the EM drive. Or maybe a slightly different way of looking at things. This light bulb takes 100 watts of power to run. That's 100 joules per second. So the power to run this light for just 1 second is 100 joules. So if I were to give that energy in terms of kinetic energy to a kilogram of weight.
Ballpark figures again. 1 kilogram is about 1 litre of water or ice, which is about 1/100th of my body weight.
How fast would that water bottle be going? Well, kinetic energy is half mv squared, so it's going to be about 14 meters per second. Now let's compare this to the remarkable M drive. Well, 100 watts gives you about 100 micronewtons of force. A force that would give 1 kilogram an acceleration of 100 micronewtons per second squared. So its velocity after 1 second is going to be about 100 micrometers per second. Or to put it another way, of all the energy that you put into this drive, only about 1 part in 10,000 goes into velocity. Or 1/100th% of the energy goes into velocity. Now let's compare that to the efficiency of, say, a rocket engine, which it turns out in terms of changing energy into velocity is pretty much the best thing in the market, turning about half of the energy into thrust. That's actually pretty amazing, seeing as most internal combustion engines max out at about 30%. So rocket engines convert about 50% of the energy of the fuel into velocity, whereas an EM drive converts about 100th of a percent of the energy into velocity.
Are you finished, Mr. Slade?
No, I'm just getting warmed up.
All engines require a power source. Rockets pack that energy in the form of fuel, which by nuclear fuels is basically the most energy-dense stuff you can get. It gives you the most kilojoules per kilogram. And then you take that fuel and you put it through one of the most efficient motors on the market, which converts about half of that energy into velocity. And even at that, you really have to pack the energy in to these rockets. You know, typically to get a rocket to orbit, something like 90% fuel by weight when they take off. So let's, for sake of argument, say that you could produce that thrust through electricity. Well, you've still got to pack that energy on board your rocket. Problem is, if you compare the energy in 1 kilogram of rocket fuel to 1 kilogram of batteries, the batteries optimistically contain about 1/10 of the energy of the rocket fuel. So even if you had electric engines as powerful and efficient as rocket engines, the weight of the battery fuel alone would mean this rocket would never get off the ground. Oh yeah, and the EM drive is nowhere near as efficient as a rocket motor. It's got about the efficiency of trying to move a truck by shouting at it.
But there will be a much more serious application, and that will be when we can use M-Drive for low-cost access to space, and we can start launching solar power satellites. I mean, it's a no-brainer. Once you can get low-cost access to space, then you can solve the world's energy problems. Well, I actually have no trouble with healthy skepticism. However, I was very shocked by the level of personal abuse that came back.
So, some ballpark figures. You'll recall that just to lift me off the ground with an M-Drive would require about 1 gigawatt of power. Or to look at it another way, as a watt is 1 joule per second, to lift me off the ground, just one person off the ground for 1 second, would require 1 gigajoule of energy. It turns out there aren't really batteries that can hold 1 megajoule of energy per kilogram yet. But let's just say for sake of argument that they did. That means to lift just one single man off the ground for 1 second would require 1,000 kilograms, 1 ton of batteries.
And indeed, I still get some insults on some of these internet forums. But I guess I've got pretty immune to it now and just put it down to very strange people being out there on the internet.
Oh, and just so you know, that's enough energy to vaporize you about 5 times over.
I mean, it's a no-brainer. Once you can get low-cost access to space, then you can solve the world's energy problems.
Call me skeptical, but I don't think with the EM drive we're quite into the league of hover cars yet.
In the next decade, M-Drive technology will start to be being used all over the world. I think most people will only really notice M-Drive when they can call up a personal air vehicle, land vertically outside their house. It will take them wherever they want to go, quietly, comfortably, safely. That's the sort of consumer application that we're looking towards.
Or free space travel and the such like.
But there will be a much more serious application, and that will be when we can use M-Drive for low-cost access to space. The UK Ministry of Defence and the American Department of Defence are interested in M-Drive.
And that's assuming that what they've got in the paper is correct, which it isn't. So how do they claim this drive actually works? Because it's just microwaves bouncing around inside a copper cone.
Put electrical energy into this connector here, and it produces a force in this direction which propels the thruster and anything it's connected to in this direction.
Well, they claim that due to the microwaves bouncing up and down inside this cone, that somehow generates thrust. Yeah, that violates the conservation of momentum, and that's just not going to happen. I mean, your suspicions may first have been raised by the massive press release that NASA did, how they had results that showed that the law of conservation of momentum was wrong. Oh wait, they didn't. And even if they had, NASA's not beyond putting bullshit out there. You know, arsenic-based life? And the incredible response it got from the scientifically literate press.
It may be a game changer in the search for alien life. NASA scientists unveiled a discovery Thursday that it says redefines life as we know it.
These microbes are composed of arsenic.
Instead of phosphorus.
Instead of phosphorus. So it's a huge deal because all of a sudden they're like, so it turns out that some living things could be genetically different.
Well, a major announcement today by NASA that a new form of life has been discovered right here on Earth, in California, in fact. Where
we have a new life form.
The finding in a salty lake near Yosemite National Park in California shows just how little scientists know about the variety of life forms on Earth.
We do. It's a new life form. Everybody's going crazy over it.
Thankfully, there were at least some people out there who actually read the scientific paper and called bullshit on it.
Look, no serious scientific discovery is ever prefaced by the facepalm words, "This is an artist's rendition of what we think's going on in the cell." And yet, this is what is said in the press conference.
So it was associated, it was inside the cell, it was somehow associated with the DNA, and it had this chemical environment, or it had an analogous sort of, it's like sitting at a dinner table and you and your neighbors and how we might see that you were all around. Well, what should be in the place of phosphorus looked like it was arsenic. We measured it as arsenic. And so let's look at an artist's rendition of what we think is going on in the cell. Let's roll that animation, please. So here we're seeing the beautiful, elegant structure of the double helix of DNA. And what I want to highlight is the phosphate backbone, we say, and that's the light orange balls. And it stitches together as we see the edges of DNA. It holds together the DNA, the backbone. And so what we think is happening, what all the evidence we've collected suggests, is that instead of these, we'll see these orange, light orange balls disappear. And represented by green balls, we see that arsenic would be substituting for phosphorus in the backbone of DNA. And you can see how critical this component of the DNA might be.
Now let's compare this to what is actually said in the conclusions of their science paper. How arsenic insinuates itself into the structure of the biomolecules is unclear, and the mechanism by which such molecules operate are unknown. Now, if they'd have said that in the press conference, I wouldn't be making this video. But then again, they wouldn't have anything to have announced at the press conference.
That I've isolated a microbe that's doing something very different. It can survive with exceedingly high levels of arsenic. It seems to be growing in a unique way. And hopefully, very shortly, we'll be making a very interesting announcement.
And that announcement could have a huge impact on the search for extraterrestrials.
Or it could not. Or my well-researched BBC documentary, it could just be that this great announcement where she was effectively evicted from her job and her groundbreaking paper was put on retraction watch as subsequent studies showed her results were bullshit. Yeah, I know, who could have seen it coming? But in this case, yeah, NASA, despite the fact that if this was true, it would throw away the whole rulebook on physics. Yeah, curiously, they didn't want anything to do with publicizing this. You see, it's as simple as this. Remarkable claims require remarkable evidence. And honestly, having to measure your thruster on one of the world's most sensitive balances, ain't it? I mean, with most space-type engines, it's a matter of can you build a rig strong enough to actually hold the engine down? Other than can you make an instrument sensitive enough to determine whether it's actually producing thrust or not? Nor is passing peer review for some gamma-ray dumping ground exactly a stamp of approval from the academic community. And it's not helped by the fact that other people have also got thrust out of these things, and then once they've managed to get rid of the errors, curiously that thrust vanished. Well, they claim it's all to microwaves bouncing up and down inside this cone, which is just a complete non-starter. You gotta understand that photons, while they have no mass, do actually have momentum. It's a quantum mechanical thing. So the photon drive is perfectly possible. But because photons have a lot of energy and almost no momentum, it's just one of the most power-hungry methods of propulsion ever. I mean, you don't know that photons produce almost no thrust. Otherwise, every time you turn it on a lampstand or something, it would blow itself over with the momentum from the photons. So yeah, you can actually have a photon thruster. It's just they're gargantuanly inefficient. The M drive claims to be more efficient than just a photon thruster. Problem is, that's not how physics works. Bottom line is when you get a photon absorbed or reflected, it conveys momentum. The thing is that just a photon bouncing back and forth in a cavity is not transferring any net momentum anywhere. So basically, all of this energy that they pump into this metal cone thing is being turned into heat, which is especially funny seeing as the guy claims the M drive is inherently stealthy because it has no thermal signature.
In the depths of the Pentagon, fairly high-level presentation attended by the US Air Force, DARPA, NASA, and it was actually chaired by the director of the National Security Space Office. Essentially, it provides good maneuverability, continuous maneuverability, with stealth characteristics. And clearly, M drive has no exhaust signature and therefore is inherently very stealthy.
Inherently stealthy? What the hell are you talking about? This drive, as you call it, turns about 99.99% of the energy into heat. It's basically a big heater, as you can see from the actual infrared images presented in their paper. Yeah, very stealthy.
Continuous maneuverability with stealth characteristics.
Well, so what are they actually looking at here? Well, if I had to guess, it's a phenomena very similar to a radiometer. You know, one of these guys.
Okay, so that's a radiometer. It's got black plates that get hot and silver plates that actually stay relatively cool. And so what there's a low pressure of gas in here, and when the side of the plate heats up, the molecules hitting it come away faster than when they hit it, which basically conveys momentum to this thing, which spins it. So if I provide a nice infrared light source, okay, so one infrared light source, on. There you go. It's pretty quick, doesn't it? Okay, so you may have seen suggestions that these are actually driven by photons actually hitting the dark side and being absorbed, and it's that momentum that's actually driving it around. So this is a little demo to show that's not the case. So what I've got here is some various light bulbs. That there is a LED light. Now, photons in the visible region are actually higher energy and therefore higher momentum than those in the infrared. And what you'll see is it does indeed accelerate it, but it's not exactly the greatest of accelerations. Right? So now I can try that with an incandescent light bulb. So it's mostly giving out visible light at the beginning. And what you'll see is, again, there's a pretty tepid acceleration. Even though if this was actually being driven by photons being absorbed, you would expect it to spin faster with visible photons than with infrared photons. And so this is what happens when I give it a blast with the infrared. It's pretty clear, yeah?
I mean, let me just paint you a picture here. A cavity is cold, and air molecules hitting both sides of it bounce off with the same energy that they hit it. That means that there is no net momentum conveyed to this box. Now imagine that one side of this is heated for some reason. Now when a molecule hits here, it bounces off with more energy than the one hitting the other side. And this produces a thrust for the object. And that's basically how a radiometer works. Yeah, these radiometers require a partial atmosphere to work. Now let's just say the same thing is happening here. That just for sake of argument, one side of this is getting hot for some reason, which is not crazy, you know, you're putting in 100 watts of power to this thing. Well, what would you expect if this were true? Well, you would expect that if you run it in an atmosphere, it'll produce more thrust, and if you take away that atmosphere, then the effect will almost entirely vanish. And guess what? When you run the device without air, the effect almost entirely vanishes. So for instance, they get about 10 grams of thrust when it's running in an atmosphere,
through to a demonstrator engine that could actually produce 8 grams of thrust.
And then when you remove almost all of the air, the thrust goes down by 99.9%, and you're left with an amazing 10 milligrams of thrust that could be chalked up to one of 1,000 experimental variables that hasn't been accounted for. Actually, at this point, I'm going to make a slight correction. The paper does actually say that they got the same result both with and without the atmosphere. That result was for the amazing 10 milligrams of thrust. However, both of those are a factor of 1,000 lower than the thrust that the inventor claimed that he got. However, with thrust that low, even if you manage to put a nuclear reactor on a low thrust rocket for deep space travel, the incredibly low efficiency of the engine would basically offset the extra energy density from the nuclear fuel. And even if this result was real, which it isn't, you would basically be at the break-even point with conventional chemical fuels. And trust me, when you're putting 100 watts of power through a machine and trying to track down a stray force of 10 milligrams, that's tricky. Because honestly, you just got to be practical about this. You have one result right on the limit of what can experimentally be measured, to the point where other groups who have looked at this retracted their results when they actually found some minor error in their measurement. And this thrust is right on the limit of what can actually be detected with the most sensitive instruments. And the guy who originally thought of this physically nonsensical idea is a crank who thinks that such devices, which can barely produce any detectable thrust, will do all of this.
It will give us flying cars, unrestricted access to anywhere we want to go to in space. It will help provide energy for the world and solve the global warming problem.
In the words of the inventor, check the maths for yourself. Well, Einstein, I did, and you're talking crap. But hey, if I want an engine that's 1/10,000th of the efficiency of a regular rocket engine, that runs off an energy source that's 1/10th as powerful as rocket fuel, all to produce a thrust that is barely detectable on some of the world's most sensitive scientific instruments, then I'll know just where to come.